I am Illuscri, and this is From Nothing to Us. Book 1, From Nothing to Lucy. Chapter 1, Nothing Then Something. This chapter takes place everywhere and lasts from the first moment to 375,000 years into the story of the universe. At the beginning of time, if there even was such an event, there may be nothing, or perhaps there was always something. Perhaps ancestor universes have expanded and contracted into the infinite past, or two multidimensional objects just collided to spawn the universe, or something stranger still. But if there is nothing, something happens to make something. The nothing may have been eternal into the past, but it clearly had an end eventually, if it ever was. So, something there is. That much is known to be. And it is hot, far hotter than tiny humans can comprehend. Hotter than the stars that burn around us, hotter than supernovae, denser than most everything we can even theorize about. Not only a single something is this hot and dense, but everything. The whole universe, whether infinite or finite or a single point, is condensed to such pressures as to dissolve all meaning of known physics. Nothing makes sense. All surrenders to the heavy hand of quantum fluctuations that morph and mash around the fabric of reality. What's everywhere can barely be described as matter using our definitions, to the point that I must throw up my hands and conclude that it could be anything at all. As if that isn't enough, all four of our fundamental forces might be combined into one, or at least are of the same strength and so are practically one. For as long as things stay like this, time has no meaning. Nothing new happens. We could be here for millennia or a single Planck time, and it would make no difference. Perhaps an eternity passes in this state of inert calamity. But the universe seems to eventually grow bored with this state of affairs, and so it all expands. Not out from a single point, mind you, but from everywhere. The whole of reality like the surface of a great four-dimensional balloon being blown up by some flavor of God. Perhaps the image of a balloon isn't enough. Not that it isn't visually helpful, it's just far, far too slow to get across what happens next. After only 10 to the negative 43 seconds, the force of gravity separates from that grand unified mass as the density of the universe decreases with expansion. At around 10 to the negative 36 seconds, the latent energy has calmed enough for the strong force to separate from the others. Whether for this reason or some mysterious other, space suddenly convulses so extremely that from now until 10 to the negative 32 seconds, the universe's rate of expansion explodes. Space pushes things apart faster than the speed of a light. Quantum fluctuations from a mere instant before become vast areas of higher and lower density, the unimaginably tiny having become the very beginning of grand structures. Had this extreme expansion begun a moment earlier or later, this pattern may be quite different. The region of the universe that's possible to be seen, a bubble around you, the observer, called the observable universe, expands anywhere from 10 to the 26 to 10 to the 78 times. Such numbers were not meant for human minds, and so I won't even attempt to explain them. I implore you to instead look around and bask in the insanity of it. At the same time are born particles. Some die quick as they're created, but others stick. The creatively named W and Z bosons are among these, as well as the Higgs boson. The latter, in its greed for power, has the ability to strike some packets of energy with a need for mass, and thus physical matter becomes possible. Such particles are weighed down, thus chained from achieving the speed limit of the universe. Massless bosons get to travel at that numbing speed of light. Even after this period of great inflation ends, this creation of particles continues, and at 10 to the negative 12 seconds, an eternity compared to the time before great inflation, it grows more substantial. What forms is a plasmatic sludge of a nearly frictionless liquid called quark-gluon soup. Quarks, electrons, and neutrinos of all flavors arise from this sludge to buzz around in the rapidly cooling universe with their accursed mass. The quarks generally have more mass than their smaller cousins, though the tau particle and tau neutrinos are able to compete with the smaller quarks. Most neutrinos, though, are so small as to nearly not be there at all. They flit through the sludge, only weakly interacting with gravity and the combined electroweak force permeating all things. The other massive particles interact greatly with the electroweak force, thanks to a thing called charge. Electrons, mesons, and tau particles, all cousins of the same ilk, all have negative charge, while quarks either have positive or negative charge depending on their type. With extreme temperature buzzing everything about, the soup is especially roiling from all this charge, as expansion does its patient work. Quarks have their quirks, like so-called color and strong force interactions, making them a little stranger and thus more interesting than electrons and their cousins. Unfortunately, these interactions aren't allowed to shine yet. Something to note as you look around now is that all these particles so far, from the bosons to the fermions, have no real size. You can zoom in as far as you want, and you'll find they keep looking like points. What does distance mean in a world of things without size? Thankfully, force interactions, namely repulsion, come in to save reason, as unreasonable a place we're in, and particles are able to exist at reasonable distances from each other without being crunched down by gravity all the time. Even so, it's a dangerous life in which the zoo of particles find themselves in, for there exist two kinds of matter which abhor each other. Each type of particle, quark, electron, and neutrino, has a version of itself with the same mass, but opposite charge. When one meets its opposite, they destroy each other in a fantastic burst of energy and light that would be brilliant to watch if it wasn't hot enough to melt any observers. So, woe fills short lives doomed to end in annihilation. But just as quickly as they are destroyed, the extreme energies birth more to continue the cycle. Miraculously, mysteriously, one of the two types of matter has slightly higher numbers than the other, about one extra for every 100 million particles. This creation lasts until 10 to the negative 6 seconds after the functional beginning of time. Expansion has spread out cosmic energy enough that the temperature dips below 1,000,000,000,000 degrees. Not that that means anything to you, of course. Any degrees above several thousand, whether it's Kelvin, Celsius, or Fahrenheit, would kill you instantly anyways. Until now, quarks were moving too fast to do anything significant, and if there's anything to know about quarks, it's that they hate solitude, and the chance to group up has now opened in all the universe. With the helping hand and blessing of the strong force, larger particles form from these holy unions of quarks, and they are the first things to have what we could call size. Several combinations are born, such as pions and kaons, but there are others who are much more important. The stars of the show, protons and neutrons, are made of up and down quarks, such that protons have one electron's worth of charge, but positive instead of negative, and neutrons have no charge at all. It's around this time that quarks, and thus protons and neutrons, stop being spontaneously created from the latent energy of the universe. No net creation happens beyond this point, though annihilation continues. Protons, neutrons, and their hateful opposites collide one final time in a grand array of death, the largest war that ever will be. Through these raging instants, some survive thanks to their miraculous abundance. It's a vast wonder that the universe does not end in utter calamity in these short moments. But it doesn't. The victorious live on, and the losers are named antimatter, perhaps the most significant case of the winners writing history. And now we reach the time when 1 second has passed. Energy has now spread out enough for no new electrons and their antimatter cousins, called positrons, to be spontaneously created, and so they go through their own war. It should be clear to you by now that electrons win this, though by paper-thin margins. And as this happens, space continues to expand, and keep an eye on those spots of higher density. From about the 10-second mark to the 20-minute mark, temperatures and pressures everywhere are about equivalent to the core of a star. Protons and neutrons are not so energetic anymore that they can't be forced together, despite their misgivings about the partnership. These unions of fusion are, if a bit prematurely, called atomic nuclei. Now, they aren't the center of anything yet except their own universes, but it's convenient to call them that going forward. Of course, one nucleus, that of hydrogen, has been around since the 10 to the negative 6 second mark, but that's cheating a little since it's only a proton. Produced in these chains of reactions are the nuclei of deuterium, then helium-3 and tritium, then helium-4, and eventually lithium-7 and beryllium-7. There's unfortunately not enough time spent in these conditions to forge heavier nuclei like those of carbon, nitrogen, iron, and beyond, though it is possible. For now, the universe has only managed the lightest of elements. By the end of this wild creation, really only hydrogen and helium-4 nuclei have any significant numbers, having about a 3-to-1 ratio respectively, of all of the visible mass in the universe. The others only survive in small amounts, and some aren't especially safe. The unfortunate souls of tritium and beryllium-7 are unstable and doomed to decay into lighter nuclei. Perhaps the most disappointing thing right now is that even if you have a suit that can keep you alive in these conditions, you wouldn't be able to see farther than where the glass of your helmet ends. Those pesky electrons buzzing around you, along with some of the protons, are busy scattering light before much of it can reach your eyes. So past whatever is directly touching your suit, you have basically no information of what is going on in the universe. With that, we have passed through that era of ultra-fast change. You may either find a way to fast-forward time, or crack open a very good, very long book, because you're about to be waiting for some time before something else significant happens. Sure, space continues to expand, but it will just keep doing that from now on anyways. And, as always, keep an eye on those areas of slightly higher energy. I suspect it has already happened, but at some point a mysterious thing called dark matter is created. You won't be able to see it, you won't be able to feel it. If you're somehow able to look very closely at how normal matter clumps around, you'll be able to notice that there's something off about its clumping. Those areas of higher density slowly become more massive than you would think with the amount of visible matter. And thus, either there is something wrong with gravity, or there is more mass there that we cannot see. So we name the hypothetical missing mass dark matter. Whether or not it's actually there, or gravity truly does not act like we think it does, dark matter is a mystery to us. Though if it does exist, it would dominate normal matter in terms of mass, about 6 times more. Even stranger still is a form of equally undetectable dark energy that, through some form of hatred for the rest of the universe, is pushing on space, trying to expand it. Luckily, the density of matter has played well into gravity's hands so far, and dark energy's pushing has been checked. Still, it is over twice as plentiful as dark matter, and expansion as a whole is far from going away. Anyways, you'll have plenty of time to think on all this weirdness. You might get antsy after a few days of nothing happening. After a month, you'll be worried this is all there will ever be, despite what you may know of the future. After a few years, you'll be convinced the period of the universe you came from has always been a lie, and there is nothing to be but this inert sludge of nuclei. If you're willing to stick it out, though, do not fret. Your patience will eventually pay off. The first time you may look up from your really long book is at around 45,000 years. Something nearly invisible happens at this time. Matter, that stuff that creates and interacts with gravity, for the first time has roughly the same density throughout the universe as radiation. This may sound dull, but it has a reaching consequence in that the expansion of the universe begins to slow. It doesn't stop, though, just slows. That is all for this moment. To your eyes, nothing interesting has taken place. The only thing you may have noticed is that electrons are ever so slowly pairing up with protons. As quick as they do, though, the temperature jolts them apart again. But as time goes on, more and more of these pairings last, and the universe becomes ever so slightly translucent. Though not very far, mind you. As for now, you may continue reading. Now, finally, after all your diligent waiting, welcome to around the year 375,000. In the meantime, some very basic clumping of matter has begun to happen, the first hints of structure in the greater universe, and electrons have continued to try and vainly stick to protons. Since you started this long wait, the observable universe, or at least what will become the modern observable universe, has grown to be millions of light years in diameter. The temperature is also a fair bit lower, and in just a moment, it's going to dip below 3,000 Kelvin. Suddenly, everywhere, all at once, more electrons than not are able to stick to the nuclei they pair with. The whole universe in a moment becomes fully transparent. All around you is a faint red glow. The light that's now allowed to fly freely has that high of a temperature, though the peak of its glow is in the infrared. Otherwise, there is no real structure to see, just that flat glow. Still, you should be rejoicing. This is the beginning of information being able to flow across empty reaches of space. Not that empty space is quite a thing yet, most likely. It's all still a flat expanse of superheated gas. And oh, the information from this moment of atomic creation will go far. You can think of a 3D screenshot having just been made of the whole of reality, radiating out in all directions from everywhere. A nearly flat wash of cosmic background radiation has just been born that will last until the end of time. I hope you enjoyed this first proper chapter of the series. If you did, let me know. This is the part of the show where I'll be reading comments and answering whatever short questions you have. Wherever you're listening to this, there should be a comment/rating system, and I know Spotify has a question box somewhere for every episode. YouTube also has a comment system, and you can also follow/subscribe if you so please, if you want to see future chapters. But since this is the very beginning of the series, I don't have any comments yet to read out in this section. So yeah, future chapters should be longer. This was a sort of proof of concept on my end, and I think it succeeded at that end. Yeah, it might have been a little bit disorganized at times, a little bit scatterbrained, but I still want to continue this series, hone my craft, and I hope you join me. So for now, farewell, and make sure to absorb the world some today.